Good evening, everybody. This problem would be very simple outside of the fact that there's kind of a notational ruse right here. It's almost obfuscation. We're given that this quadratic expression has two distinct integer solutions. And that would be a trivial problem pretty much, other than you just have this strange looking coefficient here. Now let's just momentarily forget that that coefficient is there. You would know that you would need something like this, x squared plus, let's see, we need a plus right here, so we would need x squared plus 60x, I think, and then minus 61 equals 0, right? And that's simply because we have the benefit of 61 being a prime number, or that part's not it really, but we'll sort of, but we could write this as x plus 61 times x minus 1, right? And again, I'm ignoring the fact that we have this strange looking linear coefficient here, okay, equals 0. And that's an important thing to observe because this form here has to be positive. Notice that you're just summing up ones and you're starting at 7 and you're trying to find out which integer you have to go to get the right number right here. Okay, that's all that's really going on right here. Now, just a little bit of forewarning about this notation if you haven't seen it. It's a little strange just to see a 1 there that has no there's no index or anything. We're just going from 7 to m, okay? Now, some people might prefer saying I equals 7 right here. I don't know really if that's necessary, but if you like that, that's fine. But there's no dependency on I right here. So this is starting at 7 and going to whatever the value of m is. Now, so let's take a look at what this really means. And this used to always, it's confused me and many, I think, over the years a little bit because it's not quite what you would think. If you have n and m where m is greater than or equal to n, okay, and you're summing up ones, okay, this is always going to equal to m minus n plus 1. And the simplest example I can think of to show you that, if you had, like, say, summation from 1 to 2, I'll write I if you want to there, I equals 1 to 2, and then put a 1 here, and I'll put that, there's no I there, that's a 1, right? It's tempting to say this would just be 1, right? But you really have, this is actually equal to 1 plus 1. 1 plus 1 equals 2. So that's why you have to perform the subtraction and then add another 1, okay? Those of you who knew that, you probably already turned the video off, but if you don't know that, this problem might be somewhat of a challenge, okay? So what we've seen is that this would have to be m minus 6. If you take that logic I just said, this would turn into m minus n minus 1, or m minus 7 minus 1, which is m minus plus 1, which is m minus 6, sorry. Okay, so we know that m minus 6 has to equal to the 60 that we noticed at the beginning of the problem, okay? M minus 6 is equal to 60, which tells us that m is 66. And again, a problem that's not deep in any sense of the word. It just depends on some obscure notation seen in an unlikely place. I mean, how many times do you see the coefficient of x represented like that? Well, that's actually what a lot of problems are about. They're about deception and obfuscation. As much as we hate to admit it, half the problems in these competitions are just based on some trick that the creator thought of. Like, and this is that way at a lower level, okay? I mean, nobody in their right mind would even put this in front of x. You know, it's not normal to sit there. But since this summation produces an integer, it's okay to put it there. It's just like, what are you doing, you know? But you're turning a routine, banal, everyday problem into something with a little more flavor, I would say. But anyway, I did get m equals 66 for that. And notice there would have been more than one possible m if this hadn't been a prime number. I think I haven't worked through it carefully. But if this is a composite number, you have other divisor pairs you have to consider, right, for it to work out. Maybe not. Maybe it still works out to the same thing. I'm not sure. But 61 being prime minimizes the number of things you have to look at in order to get a value for m and declare it. I'm pretty sure this m is unique. So m equals 66 is the answer I got.